Hello everyone. Today I am here to discuss the phase diagram of one component system. After studying this lecture, you shall be able to understand how to calculate phase, component and degree of freedom. Know about the basic terminology of phase rule. Understand one component system of phase diagram. Now let us discuss one component system. In one component system, the number of degree of freedom seems to be related to the number of phases, which can be easily represented by this table. This table represents the system that is gas, liquid or solid, having the number of phases 1, degree of freedom is 2, so the system is bivariant. If we consider the system gas liquid, liquid solid or gas solid, then the number of phases is 2, degree of freedom is 1, so the system is univariate. If we consider the system gas liquid solid, then the number of phases is 3, degree of freedom is 0, so the system is invariant. Now let us discuss one component system of water system. Water system is the most common example of one component system. It can exist in three phases: solid, liquid and vapor. The three phases may occur in four possible combinations in equilibrium, that is liquid vapor, solid liquid and solid liquid vapor are in equilibrium. Feature of the phase diagram are as follows. Number 1. The curves OA, OB, OC and OC dash. Areas OAB, that area. OAC, this area. And OBC, that area. And the triple point O. The significance of each of these features are as follows. First, we consider curves. Curve OA. This curve OA represents the equilibrium between ice and liquid water at the various pressure. The curve shows the effect of pressure on the melting point of ice. As we can see, the curve OA inclines towards the pressure axis, which shows that expansion takes place on the freezing of water and the melting point of ice decreased. So, by increasing in pressure, the upper point of the curve is OA, that is 2000 atmosphere and 20 degrees Celsius. Beyond this point, one type of this ice changes into another solid, but the solid-liquid equilibrium still remains there. This system is univariant and the degree of freedom is 1, which is easily shown by the phase rule equation. Now, let us discuss the curve OC. OC, it is a vapor pressure curve or vaporization curve, as it represents the equilibrium between liquid water and vapor at the different temperatures. So at every point of curve, two phases are present. The starting point O of the curve corresponds to the freezing point of the water, that is 0.0075 degrees Celsius at pressure 4.58 mm. So the curve ends at C, the critical temperature 374 degrees Celsius and the pressure 218 atmosphere. So beyond this temperature, liquid water cannot exist. So at 100 degrees Celsius, the vapor pressure of the water equals to the atmospheric pressure, that is 760 mm. and therefore is the boiling point of the water. So we apply a phase rule equation. F is equals to C minus P plus 2, that is 1 minus 2 plus 2, means the degree of freedom is 1, means system is univariate. Now we discuss another curve, that is OB, that is called sublimation curve, which represents the equilibrium between ice and vapor, and it is called vapor pressure curve of the ice. The curve starts from the point O and ends at B, that is absolute zero. This curve shows the effect of the pressure on the freezing point of the water. So this system has a degree of freedom is 1, which is easily shown by the phase rule equation. Last curve, that is the curve OC dash. The dotted curve OC dash is a continuation curve of OC curve, and represents the vapor pressure of supercooled water. With due care, it is possible to cool water of any liquid below its freezing point without separation of ice, and the water is then said to be supercooled. The liquid are in the equilibrium with vapor system along the curve OC dash is said to be a metastable equilibrium, as even the slight disturbance in this phase changes the supercooled water to ice, and the curve merges into the OB. This curve OC dash lie above the curve OC and shows that the metastable system has a higher vapor pressure than the stable one at the same temperature. Now, let us discuss the areas. The diagram consists of three areas, that is OAB, this one, OAC, this one, and OBC, this one, which shows the condition of pressure and temperature under which a single phase water vapor, ice, and water is capable of stable existence. Then by the phase rule equation, F is equals to C minus P plus 2, which is equals to 1 minus 1 plus 2, that is degree of freedom is 2, means the system is bivariant. Now we discuss triple point O. At this point, these three curves OA, OB and OC meet together, and all the three phases are coexist. The point O represents the triple point. Temperature and pressure are fixed at 0.0075 degrees Celsius and 4.58 mm respectively. The effect of heat will simply result in more of the solid melting, but there will be an increase in temperature or pressure until all the solid has completely changed into liquid. Then the system will change from non-variant to univariant. Similar is the effect of pressure. Thus, the system has 0 degree of freedom at the point O and can be shown by the phase rule equation. F is equals to C minus P plus 2, where C is equals to 1 and P is equals to 3. So 1 minus 3 plus 2, which is 0, means the system at the triple point is self-defined. So on the basis of our presentation, these are some practice questions like explain the one component phase rule with suitable diagram, discuss the significance of water system with suitable diagram, explain curves, areas and triple point in the one component system. These are some references. Thank you.